Welcome to part 2 of 3-part AutoCAD 3D beginner series. In this part, we'll discuss the following topics. We'll start with understanding the user coordinate system, which is really very important for understanding the way AutoCAD 3D works. Then we'll also talk about dynamic UCS, shell feature, section plane, fillet and chamfer tools, Boolean tools, and finally 3D array. So these are some of the topics which we'll discuss in this video. So with that, let's get started with the user coordinate system. For making drawings in 3D space, understanding UCS is extremely important. Now let's start with this kind of shape. Now here we have a drawing with several different faces, and these faces are in different planes. In AutoCAD, you can make drawing only on the top plane or XY plane. Now currently we don't have UCS anywhere in the drawing area and we cannot see what the XY plane is. So you can go to this coordinates panel and from here just activate show UCS icon. Right now it is hidden. So you can select show UCS icon and now it will show up on the bottom left corner. And now you can see XY axis here. So XY axis happens to be this grid plane, or you can also see this green and red line which happens to be the XY plane. Now this is the only plane where you can make your drawing. Okay, before we explore this further, let's check the other option, which is show UCS at origin. If you select this option, UCS will show at the actual origin and not at the bottom left. Of course, you can select the last option if you want to hide it. Now in this case, I'll keep this UCS at the origin because it makes more sense in this way. And now I'll start making something. So here I'll just go to the circle, I'll make it, and as you can see, it will make it on XY plane. Now I'll go to this front plane, which is this plane, and now I'll try making the circle again. And well, this will happen. It won't make a circle. But if I move it once again back to this, well, the circle is made, but it's made on XY plane. So that's the problem with AutoCAD. It won't let you make your drawing on any other plane other than XY or the top plane. So what are the options? Well, the options are also pretty straightforward. If you want to make a drawing on any other plane, simply make that plane the top plane or XY plane. Now let's for a moment assume that I'll first switch to parallel here. Now let's for a moment assume that I want to make my drawing right here on this plane. So in order to do that, what I'll do basically is I'll go to coordinates, and underneath this drop down, I have an option called face. Now I'll select this option. Now I'll select the face on which we want to make our drawing and then press enter. That's done. Now this face is XY. So if I go to circle and if I make my drawing anywhere, it will make it exactly on that face, just like this, even if I change the plane. Now let's say we want to make our drawing on this one. So for that, once again, go to face, select this, enter, and now you know what will happen. So now this plane is our active plane. It somehow missed it. So I'll repeat it one more time. So face, this one, and enter. It looks like it is selecting this plane instead. So maybe I'll repeat it just one more time. And now here we are. Now it is selected. So if I make a drawing now, it will make it exactly on that required plane. Now there is another way of making things as well. But before we do that, let's reset the location of UCS, because as you can see, as I made all of these things, the UCS location has changed and you can see it from the view cube. It's now at a weird location like this. Now to switch it back to default, simply click on this world UCS icon, which is on the top right corner of coordinates panel. And it is back to default. Now we have an option called dynamic UCS, which will let you make your drawing on any plane of your drawing. So here we have a status bar, and on this we have dynamic UCS right here. It looks like UCS with a lightning symbol. If you don't have this dynamic UCS, simply go to customization and activate dynamic UCS. This should be checked. Now it will show up and then click. All right, this is active. You can also activate it using F6 function key. Now, as you know, XY is the bottom plane, and let's say we want to make our drawing here. Now without changing this face, I can now make my drawing directly by hovering my cursor on a plane. So I'll select circle. Now I'll hover my cursor here, and as you can see, the plane is highlighted. Not only that, the plane of UCS will shift temporarily. Just look at the view cube. As I'm hovering it here, the view cube will shift temporarily. And if I move it to this plane, the view cube has shifted. Now the left side is top. If I move to this one, well, the right side is top. So here I'll just maybe click, make my drawing, and there we are. And in a similar way, I can make it on any plane. Now, the only condition for this to work is you should have an existing plane or an existing 3D solid. But the previous condition will work even if you don't have anything in your drawing. Now let's see another situation. So here I'll go to this right view, and let's say we want to make our drawing right here, but we don't want to use reference of an existing plane. Now in that case, of course, if I directly make my drawing, well, AutoCAD won't let me do that. So you can just go to this same option on the coordinates panel and select the first one, which is view. Selecting view will just ensure that whatever your view is, that becomes XY, and now you can make your drawing in that plane. Once again, you can switch to any other view, for example, this one. Now just go to this coordinates view option, and now this is XY. So once again, we can make our drawing in this one. Once you are done making all these changes, you can simply click on World UCS to return back to the default location of UCS. Alright, so before we move any further, I have a quick message for you. If you are enjoying this 3D tutorial series, then I'm sure you'll love our video courses as well. So on SourceCAD, we have video courses on AutoCAD, Fusion 360, SolidWorks, and lots of other software. And if you want to have a look, just click the link in the description of this video and explore our course library. You can also start with a 7-day free trial without any risks. And if you start the trial, you are also protected by a 30-day money-back guarantee. So there is a lot for you in SourceCAD video library. Now, back to the video. So let's now talk about the shell feature. So here we have these three solids which we created in our previous example of loft feature. Now all of these are created using the solid feature, so they are completely solid, but now using shell feature, we will make it hollow. So the shell feature is on solid editing panel right here. So in this drop down, we have the shell tool right here. Select it, and now select the solid which you want to make hollow. So I'll select this, and now select the face which you want to remove. So in this case, I'll select this face on the top. All right, and now press enter. Now specify the distance of wall. So here I'll add 0.1 as wall distance and press enter. Now here we are. Press enter couple of times to exit this command, and we have this hollow profile. So it will just remove that top plane, and it will create a thickness of 0.1 as you can see here, and we have this shelled profile. Now if you want to see inside, then you can do that using section plane. The section plane tool is right here on the section panel. So select section plane, and I'll select just a plane to make a sectioning. So I'll go to orthographic view, and I'll select the front plane. Why front? Because front plane will create a section like this. So I'll just select front, and here we are, we've got this sectioning. So as you can see, we have this hollow profile. It's completely hollow from inside, whereas all of these other solids are, solid. So that's the section view. You can simply select it, and you can just move it using this gizmo to see it from different distances, just like this. Also, you can delete this plane and it will return back to the default. Now, if you want to make a shell feature without selecting a face, then you can do that as well. For example, in this case, let's say we want to create this shell without removing any face. We just want it hollow from inside. So go to shell, select the solid, and simply press enter without selecting a face to remove. Now add the offset distance, which is the shell thickness, and press enter. And we are done. Now the profile is completely hollow. Now, how can we see that? Because from this perspective, it looks exactly the same. So once again, we'll go to section plane, orthographic, and select the front plane. And now you can see that this is hollow from inside. So in this way, you can create these hollow sections. Select the plane and delete it. Now let's talk about the solid fillet and chamfer tool. So I'll go to this fillet and chamfer. And with this, you can create rounded and sharp corners. So here we already have this sharp corner here, but I just want to add fillet and I just want to make it smooth. So I'll go to solid for that. And here on the solid tab, we have the fillet tool on the solid editing panel. Select this fillet edge. Now select an edge, and in this case, I'll just select this edge. But before selecting it, I want to select a radius. So I'll just go to radius. And here, I think we should select a radius of, let me just check the scale on which we are working. So the scale on which we are working is about 20 or 30 units. So I guess I should use a radius of 30 units. So I'll type 30, press enter. Now, depending on the scale, the radius value may change. And now I'll select this edge and press enter. And here we are. We have this tiny fillet. Now the fillet is added, but if you want to increase the radius, you can click this grip and just make it larger simply by moving your cursor. Once satisfied, press enter and we have this rounded corner, the filleted edge. Now let's see what else we have in fillet. So I'll go to fillet and here we have an option called chain. Now using this chain option, you can select all the edges which are connected tangentially. For example, this edge is connected with this in tangential direction. So these two are tangent and this is connected again with this line and again it is tangent right here. So if I select chain and then if I select any of these edges, it's going to select all the three edges. Of course, the radius is the previous one which I want to decrease in this example. So I'll go to radius and I'll just make it 50 unit and press enter. Now with this smaller radius, press enter twice and here we have it. So we've got the fillet. Now let's repeat it one more time for this side. So I'll go to fillet. And now instead of chain, I'll select loop. Now loop will simply select the entire loop. So if I select this edge, it will select the tangential edges as well as all the connected edges. So it will just select this entirely and this edge happens to be connected with this face too. So that's the first face, but you can click on next and it will select the second face. If it is connected with more faces, it will just select that as well. But if I click on next, it will go back to the previous one because no more faces are connected to this edge. So with that, I'll now click on accept or maybe press enter again. And this will apply the fillet of 50 unit radii. Press enter twice and here we are. So the fillet is applied on all of these edges at once. Now in a similar way, you can apply chamfer, but chamfer will edge just sharp edge. So it will remove the sharp edge, but it will then add a wedge kind of shape. So select chamfer and just like radius, in this case, we need to add distance. So go to distance and specify a distance value, which I'll select maybe 40 for the first distance and 40 again for the second distance. Now I'll select this edge right about here and here we have the chamfer. Press enter twice and here we are. Let's repeat it one more time. So I'll select this chamfer and I'll press enter. Now you can change it non-uniformly using these grips. So you can just select this grip to move it here and this grip to just move it here. So non-uniformly we can change chamfer just like this. Press enter and the chamfer is done. Now let's talk about the Boolean tools, which is right here. Now using Boolean tools, you can make geometries using combination of different solids. Now there are three Boolean tools. We have it on the Boolean panel, union, subtract and intersect, and it is available on solid tab. Now let's start with union. So in this case, I'll use this geometry and as you can see, it is made with several different solids. So that's a solid. This one is a different solid. This one is again another one and this one is another one. So in total, we have 4 solids, first, second, third and fourth. Now, if you want to combine it all into one, then you need to use union because if I don't combine it and if I let's say select move command, which is right here, if I select any face and then if I try moving it, well, it will move only that solid. It will leave everything behind. And of course, we don't want that. So I'll press Ctrl Z. I'll go to solid and I'll select union. Now select all the solids which you want to combine. And the only thing that you need to keep in mind is these solids should be physically connected. And in this case, all these solids are physically connected. So it will combine it and merge it into one single solid. So press enter and here we are. We now have one single solid shape. And that's the union tool. Then we have subtract. Now using subtract, you can subtract a solid from another one. So select subtract and now select the solid which you want to keep or your main geometry. In this case, this is my main geometry. So I'll select this and press enter. Now select the subtracting geometry or the geometries you want to remove. I want to remove these 3 cylinders and this shape. All right. So with that, press enter and this is subtract. So from this main geometry, all of these are now subtracted and we are left with this. So that's the subtract tool. Finally, the intersect tool. Now using this intersect tool, you can extract the common solid. So we have 2 solids here, this one and this one. Now let's just select intersect, select both of these and press enter. And this will leave you with the common region, which happens to be this one. So this was the only common volume available. And that's what you'll get when you use intersect tool. Now finally, let's talk about arrays. Now if you are familiar with 2D arrays, well, the things are pretty much similar here. And here you can use the 2D array as well as the 3D array tool. I'll start with the 3D array tool. So I'll go to Home tab, and actually you won't find 3D array anywhere on the panel. So you need to start it with command 3D array. All right, press enter. Now select the object. In this case, the object is this cuboid. So I'll select this and press enter. And now you can see that we have just two options, a rectangular array and a polar array. All right, let's select rectangular. And now you just need to specify number of rows. All right, number of rows along x-axis. So let's type 3 for that. Number of columns, let's make it 4. And well, the level is along z-axis. Let's make it 5. All right, done. Now we just need to specify distance between row, which is the distance along x-axis. So from this to this point, you just need to specify that distance. So the distance between rows, well, I'll just make it 30. So 30, enter. Now the distance between column, let's just make it 40. Enter. And the distance between level, well, let's just make it 20. And press enter. And here we have it, the array. Now to see this clearly, you may need to orbit your drawing. And here we are. You can now see it along x, 30, 40, and 20, or whatever the distance we specified. So that's our 3D array. Now, if you want to make a polar array, the workflow will be similar. So press Ctrl Z a couple of times to get back to this original drawing. And here, once again, I'll type 3D array and enter. Now I'll select this cuboid and enter. And now select polar array. All right, now this will let you rotate your array about an axis. So in this case, you need to specify number of items. Well, let's start with 32 items. Enter. Now the direction counterclockwise or clockwise, you can select that. And for counterclockwise, it will be positive. For clockwise direction, it should be negative. So always we are using the anti-clockwise rule. So here anti-clockwise is positive. So you don't need to worry about the positive and negative direction. Simply add an angle. So here maybe just type 360 or simply press enter to add an angle of 360 degree, which will fill your array along complete circle. So in this case, as 360 is already selected here, I'll simply press enter. Now it is going to fill that entire circular path. And now we have an option. Do you want to rotate the arrayed object? Well, select yes for now. And now we specify the center point of array. So I'll maybe just select a center point somewhere here. And then I'll specify another point right along this top axis. And this is what we are going to get. So as the array objects were rotated, you'll notice that all these objects are rotating with respect to center. So as it is rotating, so are these objects. And it is all rotating about that vertical axis which I selected. And that's the polar array. I'll press Ctrl Z a couple of times to get back to the original drawing. And I'll do that one more time. So 3D array, enter. I'll select this object, enter again. This is polar. Number of items, well, let's make it 36 now. And angle, well, let's just make it 270 this time. Enter. Now this is the rotate arrayed objects. Well, let's make it no. And center point, I'll just make it like this. So there we are. In anti-clockwise direction, we now have the array and these rectangles are no longer rotating. So this is the actual rectangle. Now the second one is exactly aligned with this. So these two are parallel. So these are parallel and so on. So they are all parallel. But if you rotate it, it will all align with respect to center. Now, I've created this spline for a reason. So let me just get to that now. So I'll press Ctrl Z a couple of times. And the only array missing from this was path array. So we had rectangular, we had this polar, but the path array is available in 2D. So on the modify panel, we have the path array right here. And if we don't have path array, it doesn't mean we cannot use it. We can still use this 2D path array tool for 3D objects. So I'll go to path array. I'll select this object and enter. Now select the path curve. So well, this is the spline which I'm going to select. All right, I'll select this spline and here we are. We have got this array right along this path. Now, if you want to change number of objects or the gap, you can do so here. Right now, this will let you change the gap, which is 15. Let's just make it, let's say 20 and tab key. The gap will change. Now, if you want to change number of items, then that's here. And here, maybe let's just change it 24. Now the number of item is 17. And if you want to change that, then go to properties. And from this option, select divide. This will let you change number of items, but not gap. So only one property can be changed. So maybe I'll just make it 32. All right. So these are so many objects. Maybe I'll just make it 26. Now that's better. So that's the path array. Now there is a problem with this path array. These arrays are exactly like the original object and they are not rotating along with this path. Even if they are rotating right about here, it's not aligning with respect to path. Now to align it, you can select tangent direction. So I'll select tangent direction and I'll just select two edges here along this line. So I'll just maybe go to this one here, and here I'll just select this point and this point. Now this will happen. So let me just go to the top view here and this will happen. So as I selected this and this point, AutoCAD will ensure that these lines, this one and this one and this one, they all remain tangent to the selected path. And that's the tangent direction. So once you're satisfied, you can click close array and there we are, we've got this path array. Now in a similar way, you can use the polar array and rectangular array tool of 2D for making 3D array as well. And it will work exactly like 3D array. So these were some of the modified tools of AutoCAD 3D. So that was part 2. In the next part, we will discuss the surfacing tools and creating photorealistic rendering in AutoCAD. I'll see you in the next part.